all 100 components, and we're making use of the over-completeness of our dictionary, or the factors. And on the top right, we see the reconstruction error, and it's converging, first of all, pretty nicely. And the green and blue plots show the training and validation error for the standard reconstruction error, sort of standard reconstruction problem. And the red and black lines show a matrix completion problem, which admittedly is a pretty simple one because we only have 5% of the data missing, but we show that it's pretty stable after a certain number of iterations. And here we compare this against the PCA method and also sparse coding method. We obviously did not optimize sparse coding that much here, but still we're able to show that our method does quite better than PCA with the same number of expected components. By that I mean, if you were to do a PCA on the previous data, you would use 15 first singular values and vectors to reconstruct the original data. And sparse coding, and on the left is the reconstruction, on the right is the matrix completion problem, and we're able to outperform at least PCA and possibly sparse coding too. And the last thing I want to show is the ridge regression part of it. I don't think we had time to get into that much, though. So once you have the dictionary learned, what we're really doing is just a simple ridge regression. And here we show that given the right lambda, or the dictionary, or the factors, we are able to consistently outperform PCA unless, of course, the PCA uses all 5 components. Sorry, the dimension is 5 here, and unless PCA uses all 5 components, which will recover the original data exactly. And on the right, we show the reconstruction error with the matrix completion setting. We're not doing consistently better, but it's kind of close around, and we think the two methods are at least comparable, and the error bars intersect each other. So, and after fine-tuning, hopefully we will be able to get better results. Do you think we have time for future work?
Okay, so we have a few points for the future work. So the first one is just to run on real data, but here's the summary, and thank you.
In the future, it would be nice to get a virtual future.
Thanks very much.
Yeah, I have a question for the sampling process. So I understand since the true posterior distribution is intractable, and you are not interested in the local hidden random variable, so you use a collapsed version of the sampling. I think there's a recent approach to use a collapsed version of variational inference. And you can show that by using the decomposition assumption, decomposable assumption, the estimator returned by the collapsed variational inference is a raw black realization of the estimator returned by collapsed sampling, which means the variance is highly reduced. So I think it's a very good approach to use sampling, but the problem is that maybe the variance can be very high, and I think it shows in the figure, which is the error bar has a very high variance.
Well, probably, but we try to avoid the variational approach because of the factorization that you were talking about. We try to incorporate this dependence between the variables, and that's crucial for us. Also, when we sample and we try to optimize the determinable point process, we are working in the over-complete setting. So all these experiments are when the number of factors is much more than the number of the actual dimensions. So if we work with basically, if we don't restrict and we don't have these dependencies, some of the matrices might turn into basically singular, and the gradients will explode. So the determinable point process fixes that itself. That's a good point. section. So.
This is unfortunate. Just want to email it to me.
Yeah, I can do that.
While we get this set up, everybody, your last homework is graded, your grades are on AutoLab. And at the end of class, your group can pick up your feedback forms in these piles over here. Okay, and you can hopefully use this feedback to iterate on your final report, which is still due the same day it's been, we said it was, I think it's like the Monday after the week of SNPs. Yeah.
And the QR code.
Oh yeah, and there is, here, we could just hand it out now, I guess, right? There's this QR code which will take you to a course, here, let me just pass this around. I'll take you to a course evaluation page that we would really appreciate if you guys filled this out.
Additional.